Nth term. It's all about creating a rule for a number sequence. As you can see here, we have two number sequences. The n represents the position of each number in the sequence. So 2 is the first number in the sequence, 4 is the second number, 6 the third, and 8 is so on. You might be able to see this is basically the 2 times table. Okay, so but how we show this in terms of nth term? Well, nth term means where it's going up the same amount every time. Okay, it's called an arithmetic sequence. And you can see it's adding on 2 each time. So instead of writing add on 2, we'll show that through the nth term algebraically. So it's going up in 2s, and we'll call it as an answer will be 2n. What that basically means is 2 times by 1 gets us 2. So 2 multiplied by the first term sequence, so 1 gets us 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. So our n represents the first number in the pattern. So basically, that's how you represent the 2 times table, 2n. Right, this one, you might have already seen. So you can see it is still, like the one before it, it's going up in 2s. So that means it is 2n. However, it's a 2 times table, but we've added 1 each time. Yeah, so it's 2 times 1 is 2, add 1 is 3. 2 times 2 is 4, add 1 is 5. 2 times 3 is 6, add 1 is 7. 2 times 4 is 8, add 1 is 9. And that is basically the difference. Let's do a couple more examples. 2 new questions now. Think you can do it, pause it, have a go. I'm going to go through it. So, same as before, each of these numbers represents the first term of the sequence. So 4 and 2 is a first term, 7 and 7 is a second term, 10 and 12 is a third term of these two patterns, and 13 and 17 is the fourth term. Firstly, you've got to find out the difference. What is the difference? What is going up each time? And you can see it is 3. These are called linear sequences as well, which basically means it's going the same amount every single time. And so it's going up in 3s. So that means it's 3n. It's a 3 times table. However, to get from 3 to 4, the first term, I'm adding 1. Yeah? 3 times 1 is 3, add 1 is 4. 3 times 2 is 6, add 1 is 7. Similar to what I explained before. And that is it for that one. As you can see, this one is going up in 5s. If this was an exam, you would get 1 mark for identifying what is going up each time. So it is 5n. Bit different this time. Be careful. How am I going from 5 to 2? I'm always looking at the first term. How am I going from 5 to 2? I'm subtracting 3. So this term is a 5 times table, but I'm subtracting 3 each time. 5 times 1 is 5. Take away 3 is 2. 5 times 2 is 10. Take away 3 is 7. And so on. Right, let's do a few more slightly different examples now. Get a little bit more tricky. If you've learned something, hit a like button, hit subscribe, or leave me a comment. Let me know what you've learned. 2 more sequences for you. Pause it, have a go. Okay, right. So similar before, but slightly different in difficulty, okay? Same process, we find the difference. So it's going down in 4s this time. It's -4, -4, and -4. So we can see it's the -4 times table. So it's going down -4s. So now, how do we go from -4 to 5? And that is just adding 9. And that's the difference in this one, okay? You can write, though, just for those that might question me, 9, oh, I've got the n. 9 minus 4n. There we go. So you always double check your answers. So, that's it. You can write it both ways, okay? As long as the minus is in front of the 4. Now this one is going down. Hopefully you can see that. It's going down 0.5. Or you can write as a fraction, minus a half. Absolutely fine. So now we go minus 0.5. Then what do I add to 0.5 to get to 3? So 0.5n, almost again, plus 3.5. And that is it. Loads of examples to go through. There's a good 6 for you, okay? In this video, I've shown you how to create the nth term when given a pattern. If you like what you're seeing, check out this playlist, check out my other videos, and I'll see you next time.